Okay, hi year 10. This is the first video for core chemistry, covering the first four facts which are in week 1, under week 1 in the fact book, looking at Mendeleev and the periodic table, the development of the periodic table. So, it's Mr. McNaughton, as I'm sure you've realised by now, having recognised my voice. I hope you're all safe and well. This is revision that we're doing, but it's been a while since we covered it, and hopefully it will ring a bell, but it obviously will have been a while since you did it, and it won't do any harm to go over it again. So the facts in the fact book are all based around things that you have looked at previously, but obviously, particularly given events that have taken place recently, it won't do any harm to jog your memories and do a little bit of extra revision on top of work that hopefully we'll get going with as and when things progress in terms of you guys being in school and so on. So we are going to look at the first four facts from the fact book, looking at Mendeleev and how he developed the periodic table and what he developed it from. So the first thing, just a quick recap on what an element is, because the periodic table, obviously as we know it now, shows us all the elements that have been discovered up to this point, well over 100. Now, an element, as you should know, everything is made up of matter, so anything that has mass and volume is what we call matter, and all this matter is made up of what we call atoms. Now, there are over 100 different types of atom. Each one is an atom of a particular element. So if you have a particular element, it will all contain atoms of that type. Not all atoms are the same as each other. Different elements have different types of atoms. Different elements have different properties because of that. But within any element, all the atoms are made up. All the atoms will be the same. They will all be atoms of that element. Likewise, any substance that is made up of only one type of atom is what we call an element. Okay, now all the elements, as we know, are grouped in the periodic table, and you get that in any assessment or test that you do in chemistry. And there's various bits of information you can get from the periodic table that helps you with those assessments. We're going to look at these four facts in terms of what they tell us about how the periodic table was developed by a Russian scientist called Mendeleev, or Mendeleev, however you wish to pronounce it, as long as you recognise the name and you remember these key points which you find in the fact book under lesson 1. So, in terms of how the periodic table was developed, there were various stages in this. It didn't happen overnight, and it wasn't an easy process or a simple process. But to get to the point we've got to now, there were various things happened. When it was first developed, there were less than 50 elements being discovered. Obviously, elements are still being discovered now, and going back a long time, far fewer had been discovered than there are now. So people tried to organise these to organise these elements based on their properties. Because as they were discovered, people could find out more about them. They wanted to come up with some kind of system for logging them and so on. This is very difficult to do for all elements, and also the ways that they tried to do it, there were certain problems or flaws in how they tried to do that. Now, the first person, or one of the main names in terms of developing the periodic table, was a guy called John Newlands. In 1864, so a long time ago, a long time ago, he produced a very early version of the periodic table where he basically just organised elements according to their increasing mass in terms of their atoms. Okay, so he noticed that in the grouping them that way, every eighth element had similar properties to the 8 elements before it, and so he came up with a table based on what he called the law of octaves. Octaves being reference to every 8th element. Okay, you will know in maths an octagon has 8 sides. In biology, an octopus has 8 legs. Oct means to do with 8, and therefore he came up with the law of octaves, because every 8th element had similar properties according to his system. Okay, there he is there. Now, this is a version of his table in front of you. So what he did was he looked at every 8th element, and he figured out that every 8th element had similar properties. So if we look at this lot here, we have phosphorus, and then 1, 2, 3, 4, 5, 6, 7, 8. Every 8th element showed similar properties based on that. Okay, now, where two elements happen to have the same equivalent, both are designated by the same number. So that's why in his table, in some of the boxes, you have 2 elements. Okay? And this is one of the flaws in the process that he used. But you have to remember he was operating on much more limited information to what we have available to us nowadays. You don't need to glue this into your book, but have a look at the periodic table and maybe have a think for a minute or two. If you want to pause the video, have a think about some of the problems. Have a look at some of the elements that are in the same groups, for example, the same columns. See if you can spot any problems based on what you know about the modern day periodic table. So if you want to pause the video and have a go at that now, by all means feel free to do so. Okay. So, looking at some of the limitations, I know this is not to do with Mendeleev, but it gets us to the point where we can appreciate what he did. Limitations on Newlands' periodic table, it did not take into account that we still had elements out there that we didn't know about, and so he was grouping elements based on the fact that that was all the elements that existed, and therefore in his groups you had elements that were not similar at all. We know nowadays in our periodic table that the elements in the same group share similar properties, whether it's the group 1 metals, the group 8 noble gases, or whatever. For example, in his periodic table you had iron in the same group as oxygen and sulfur. Iron shares very few, if any, chemical properties with oxygen or sulfur. So, it didn't work for elements that were heavier than calcium, so it didn't allow for any elements existing that were heavier than calcium. And he did, probably unfairly, come in for a fair amount of ridicule because of this. Remember, he was operating on very limited information, and he was trying to do something that's very difficult. But he was actually at one point even asked why he didn't just stick them in alphabetical order, because it would make just as much sense. But we did build on his ideas. So, as we said, and as the facts point to, Dmitri Mendeleev was the person who actually got us to the point, on the road to the point where we're at now. Because Dmitri Mendeleev solved a few of the problems that Newlands' periodic table had. And he developed the basis for the modern day periodic table. First thing he did, which is important, was that he ordered them based on their atomic weights. Okay? And so that way you could see a regular pattern in their properties. There's Mendeleev there. Again, I doubt you'll ever be asked to do anything with his picture, but that's what he looked like. So he ordered them according to atomic weights. But one of the key points, and this is one of the key things, if you're ever asked a question about Mendeleev in the periodic table, even if you just write, he left gaps, that's a fair chance you will pick up a mark for that. I'm not saying that's all you should write, but if your mind goes blank and that's all you remember about Mendeleev, he left gaps for elements that had not yet been discovered. So he acknowledged that up to that point we had discovered a certain number, but there were probably still elements out there that had not been discovered. The other key point was that using his table, he could predict properties of these elements that hadn't been discovered yet. One of those was an element we now call gallium, which is a metal, has a very low melting point for a metal, and various other properties. He predicted, before that had ever been discovered, he predicted there would be an element that fitted into one of the gaps in his table with exactly those properties. And then when gallium was discovered, it literally had pretty much exactly the properties he had predicted. So it completely backed up his idea. So first key point, or first fact, he ordered them based on atomic atomic weights or mass. Second key point, he left gaps for elements that had not yet been discovered, and he also correctly predicted the properties of elements that might be discovered and fit in those gaps. An example being gallium, but there are several others. Okay, when they were discovered, these elements matched his predictions. So whenever there was a gap, he could point to it and say, well, the element that goes in that gap there, based on the elements around it in my table, it will have this melting point, it will have this density, and so on. And when they were discovered, the elements matched the properties that he had predicted for them. So he left gaps, and when those gaps were filled, the properties that he predicted were actually the properties demonstrated in those elements. Some of the problems, not all the elements fitted his pattern, as we found with Newlands. For example, argon, based on just atomic mass, argon should be a reactive alkali metal, and potassium should be a noble gas. But we know from our periodic table and from the information we now have, that's the other way around. So what he did was, where there were problems like that, he swapped them to make them fit his pattern. Now, he didn't know why they then fitted his pattern, but he did swap them to do that, because he said there should be exceptions. What we found eventually was, when we discovered the subatomic particles, protons, neutrons, electrons, we could actually then give each element an atomic number, and when we put them in order of atomic number, they matched up with where he had swapped them. Okay? So he swapped around the elements. Where the properties didn't match up with his idea, he swapped them round so they did match up. People probably at the time said, well, that's cheating, but actually when we discovered more about the elements and the particles that make up the atoms, it actually showed that where he had swapped them, that made sense to do so. And now we have a periodic table that is ordered based on atomic number, and we have elements in the same groups that share the same properties, and so on. Okay, so that was what Mendeleev did, and that's how we got to the point of having the modern day periodic table that we have now. Okay, so the key points then from that, don't worry about the exam question, you're not doing that. Key points from that again then, Mendeleev left gaps in his periodic table to allow for elements that hadn't been discovered. He arranged the elements in order of atomic mass, or mass number. He swapped round elements where the properties didn't fit with the pattern in his table, he swapped them round. And eventually he was proven to be correct in doing that when we discovered enough to order them by atomic number. And where he had left gaps, he predicted the properties of the elements that could fit in those gaps. When those elements were discovered, he was proven correct. Okay. Hopefully that's cleared up, or given a bit of background to the facts on lesson 1 in the fact book, and we'll move on to the next facts for the next lesson in the next video. Okay, thank you.